All right, so here is a definite integral. It's integrating from 2 to 7, 4 minus 2x dx. Now, so far, here's what I've taught you. I've taught you that you could evaluate this definite integral by doing the limit of a Riemann sum. And we could do that. This would be not a very hard problem to do that way. In fact, I might do that just as an extra example of how to do that kind of thing. But what I just taught you in the previous video is that for some very simple definite integrals, you can basically just use geometry to figure out what it should equal. And then further back still, 2 videos ago, we went over some properties. So what I'm going to do is show you how you can approach this problem using the properties and then using the geometry, and we can figure out what this equals without ever having to do a limit of a definite integral. Sorry, a limit of a Riemann sum, which is what I meant. So let's see. First of all, we know that this is going to distribute over the subtraction, right? That's sum and difference rule, so we can use the difference here and split up the integral over the difference. And then also, I'm going to, in the same step, I'm going to go ahead and pull out the pull out the constant multiples. So this is going to be 4 times the integral from 2 to 7 of 1 dx, 4 times 1, right? And then minus 2 times the integral from 2 to 7 of x dx. So that's doing both those steps at once. Then let's use some things we know. Integrating 1, remember 1, the integral of 1 is like finding the area of a rectangle, nice and easy to do. So it's just going to be the length of the interval from 2 to 7. So this first one's going to be 4 times 7 minus 2. That was easy. All right, second one. Now this one is a little more complicated. This is an integral of x, for which we can use this idea. And I was explaining here that if you want to go from a to b instead of 0 to b, you can go 0 to b and then 0 to a and subtract. So you're basically taking the whole triangle and then subtracting off this part and leaving you with just this part. So we're going to do something like that here. We're going to replace this integral from 2 to 7 with an integral from 0 to 7, x dx, minus an integral from 0 to 2 of x dx. Now that's equivalent. Now if you want to justify that that's equivalent, let's write it first this way. We'll do this in 2 steps. If you really want to justify that that is equivalent, then you can write plus the integral from 2 to 0 x dx. Let's write it that way. Now remember, I explained earlier how if the lower limit of integration on one of them matches the upper limit of integration on the other, then when you add them together, it can be combined, going from the lower to the upper. And so that would be from 2 to 7, 2 to 7, right? And I also pointed out in that video that it doesn't matter if those things aren't in the same order. For instance, here we're going from 2 down to 0, and then from 0 back up to 7. And adding these together still gives us the integral from 2 to 7. Okay, so first we'll do that, and then to get back to where we were a second ago, we're going to reverse the limits of integration on this one, swap them, so it goes from 0 to 2, and then that is going to change this sign from addition to subtraction. Okay, so from a positive to a negative, right? Remember, flipping the limits of integration just changes the sign. So there we go. So now each of these is a triangle. This is the big triangle from 0 to 7, and this is the smaller triangle just from 0 to 2, and we're going to subtract them to get the area that's going to give us the area that's sort of between 2 and 7, like this. So what we're going to get here is, I'm not just going to write 4 times 7 minus 2 times area of the triangle of length 7 here is 1/2 times 7 squared. And then we're going to minus the area of the smaller triangle, which is going to be 1/2 times 2 squared. Just checking my notes to make sure I haven't made a mistake yet. And it looks pretty good. So this here is going to be 4 times 5, so that's 20. And then here we're going to have a half of 49. Oh hey, I forgot. In the next step I wanted to do something. I wanted to distribute this and cancel this 2 with these 1/2s. So we're going to have 49 and then minus 4. So overall, this ends up equaling negative 25. And we did it without ever using the limit of a Riemann sum. It might be nice to do this with the limit of a Riemann sum as well, just to show you what that looks like. Maybe I'll stick that in the next video.